Hi, this is Dr. Y. Srinivas Rao, Dean Academics and R&D, Sardar Patel Institute of Technology, co-founder, Go Green Technologies Private Limited. In my previous sessions, we have discussed about how to write a technical paper or thesis, and while doing, what are the do's and don'ts, and also while preparing the presentation, how to prepare a presentation, a effective presentation. The last session we have discussed about the organization of your technical document. In this session, we will discuss about some open source tools to create technical document, papers, presentations. While doing so, we recommend using Latex, which is an open source tool. Since it works, it comes under GPU, General Public License, and you can use it as many number of terminals as you want. It is a freeware. The purpose of why Latex is when you create a technical document using Microsoft Word, we have some common issues like it's not only the contents which we type it, we keep on editing our own contents continuously time to time, because anyhow we have to upgrade our technical document. Then we naturally keep on adding some more figures, some more plots, some more tables, some more equations, some more references. And undoubtedly, every figure, every plot, every equation, every reference should have a number, and it should be referred in the text in the same order, the way they appear. It's a painful job using Microsoft Word because these numbers you have to assign every time as and when you add a new data, new reference, new figure. And creating the index is again a painful job because you have to go through your entire document to refer the numbers, sections, subsections, figures, plots, equations. This is a problem. Even the equations, when you type it, they have symbols. Then it's always, you have to search for the symbols, drag it, drop it, organizing. Whenever you add some new contents, the whole document will be disturbed, the contents will be shifted, the plots and figure shapes will change. You will be referring on some page, your contents, your figures on some other page. So it's a big headache. And conference to conference, journal to journal, they have a different formats. They may say 2 column, single column with so and so space, and so on. So again, converting a document from single column to 2 columns, a painful job. So why I am saying these things is these are all our experiences, that if you use Microsoft Word, instead of focusing on the contents, your energy is going on editing your own document. So we prefer using Latex. The reason is Latex is not any editor. You can use any editor. You can use still Notepad, Microsoft Word as an editor to type your contents. But the extension of the file, when you save it, it should be .tex, plain text file. So what is Latex? Latex is a compiler. It's a scripting language. It has a set of commands, also has libraries. So by using the script commands, it will convert your text files into a image, a document, 10, 12 formats, PDF, EPS, and so on. There are options are given. So in whatever is the output file format you want, it can generate in a fraction of second, because just you have to give a command. Converting single column to double column, just a one command. It's not that you are editing again. Giving the numbering system to all your figures, plots, graphs is just a one simple command of compile. It's done. Such a beautiful language. Instead of focusing on the contents, our energy is going on editing the document, assigning the numbers. So it is really good for typesetting the mathematics and also generate various file formats, because the conference people, the publishers also ask at least 7-8 file formats. So you have to submit that, including the source files. So it is easy to customize. Creating PDF file is pretty easy. Any standard browsers can read the output files created by the Latex. And the quality of the characters is also truly a printable characters, as if a publisher has published. And no need of worrying about the licensing. It is a freeware, and time to time the repositories are available, upgraded versions are available. I am using last 20 years, absolutely no problem. Even the versions are, you will get time to time upgradations. And the other tools like in Linux, these are also freewares. The editors, the viewers, the plotters, all these tools are free. So even you don't need to buy the other tools. When you organize your contents in Latex, the organization can be done as you can see. For example, if this is your slide, your presentation slide, you can organize into 2 columns. Left side may be your text, right side may be some images or plots. But let us quickly compare what is a scripting language. The scripting language means, you can see, every slide there is a begin slide, and end of the slide called end slide. And if you have some titles in your slides or paper thesis, say slide title. Then if you want to write your text in italic form, then you say /em, which is a command, / is a command. If you want to write your text in a bulleted form, then say begin itemize. It will start, every item is a new line, and end of your bulleted statement, say end itemize. If you want to give numbers to your to the statements, then say begin enumerate. Then at the end of the statement, say end enumerate. If the slide is over, say end slide. So every slide is a file, a .ex file. So you can have, if you have 10 slides, you can have 10 files, and all these 10 slides files are included in one single script, and we say convert into a presentation PDF form. It also has some command, like you can see my bottom of the screen, first slide, previous slide, next slide, last slide. These commands are also part of the scripting language in Latex. Whenever you want to modify any of these things, if you want to remove any of the slides, simply you have to comment them. Then those slides are excluded from your presentation. And since writing the documents, presenting is a continuous process, if you use Latex, initially it may be slightly takes time to understand, maybe 1 or 2 days. But since these are all few commands, later on it won't take much time, but lot of time is saved in editing your own, organizing your own contents. So the compiler input to latex is a text files, right? And there will be a scripting language, screen style, and one major main file called show.tex, where you mention, or it could be anything, you mention all your slide files. And if you use this command called pdf latex and the file name, which is the file name show.tex, because show.tex consists of all the files, all the slides, then it will convert your text files into a show.pdf file. So final output file name is show.pdf, input file is show.tex. However, show.tex consists of number of slide files, slide 1, slide 2, slide 3, and the style of the your slide also is a library which you can include in the show.tex file. So it is as good as like a, if you recollect, like a C program where you have .c files or the inputs. You can also have some other libraries, header files, and then finally the compiler will compile and will convert into object files into a binary file. So similarly here, the .text files are converted into PDF files by using this compiler called Latex. You can organize your screen into two parts. One side you can have text file, other side you can have the maybe images from your oscilloscopes, photographs, or some plots. So your slide environment will be slide title, and then you can have a tabular environment, left side a mini page, right side another mini page environment. Left side probably you can have itemized environment, right side you can have a graphs, plots, tables, figures. So this is a nested environment you can create. You can see how nicely the mathematical equations are mentioned. No need of retyping these things again, because these are all there in your report as it is. Those commands you can use it here, it will convert into equations. Even Roman letters, symbols, subscript, superscript, everything is a command here. Even if you have programs, high level language or low level languages, there is a command which will give a different color to your slides along with your text and mathematical symbols. So this is how one can prepare your presentation. Now I will demonstrate you how to use LaTeX for creating slides, creating documents. While doing so, we can also use some other softwares, open source softwares which are available in Linux. But I have seen some students do use these softwares in Windows platform also. Right, they are available online tools also, where instead of using LaTeX, WinText, Overleaf, some online softwares are available where they, on their platform, you can upload your script, upload your text file, upload your images, then it will convert into PDF file. Though I rarely use those softwares, but maybe I will demonstrate in some other lecture. Today I will be demonstrating, right now I'm in Linux environment, all the commands, all the tools, various files and their formats, and few commands of Latex I will be explaining in this session. So this is all about open source tools, a Linux operating system, and some useful tools for writing technical papers, thesis, articles. So Xfig is one software where you can draw the figures. It's a very good software for editing pixel by pixel, including images you can import. Similarly, GNU image manipulator program GIMP is available for image processing like a Photoshop. Emacs is a editor, like as I was telling, text files, like Notepad, you can use it. Xfig, sorry, gedit is another software instead of Emacs. It slightly looks like your Microsoft editor. XMGrace is a software for data plotting, but it is also having some other analysis tools like FFT, DFT, such kind of inbuilt data analytics tools are also available. Acrobat, as usual, is for visualization of your output files, PDF files. So these are all freewares. Even Evince is available. XPDF is available for PDF files viewer. So these are all recommended tools. Extensively we have used. Otherwise, I am sure in last 15-20 years several tools might have come up. However, these are all open source, works in Linux environment. Now let us see some commands of Linux, regularly used commands. Though I am not explaining Linux or the Linux organization or the architecture, the commands, the minimum commands which are required to use these tools and write our own documents, I am explaining only those commands.